So when you're thinking about molarity, it's important to know that molarity is a unit of concentration. And so molarity is often written as this thing called big M, okay? And it's important to differentiate big M with all the other expressions that involve M. So for example, little m, little mol, mole, or moles, okay? So big M, okay, is different from these three. These three are the same as each other, okay, so you can interchange moles with mol with mole, doesn't matter which one you use, okay. Normally it's abbreviated to be mol, and this means, or it's pronounced mole, okay. Big M is pronounced molar, and little m is meters, okay, so definitely you don't want to be using little m in molecular biology too much. Now, big M molar is actually representing a combination of units. Okay, so big M is equivalent to MOL slash big L. Okay, so this is moles, and that's per, and this is per liter. Okay, so big M is essentially the exact same thing as saying moles per liter. Now, some people get confused when they're converting between millimoles and nanomoles and micromoles and whatever. Now, it's important to always note that big M is equal to MOL slash L. Okay, big M is equal to MOL slash L. Therefore, if I have an expression this which is 7 micromolar, for example, okay, this is 7 and then micro. And then big M is equivalent to MOL slash L. Therefore, we write, instead of writing big M here, we write MOL slash L. And now we have something called 7 micromoles. And then we have per, and then liter at the end. Okay, so 7 micromoles per liter. This is a volume. This is an amount. It means that in this volume, in this 1 liter, okay, there's an invisible 1 there. In this 1 liter, you have 7 micromoles of whatever substance it is you're talking about. Okay, so if you're converting between molarity and moles per liter and stuff, it's always very important to note that big M is equal to MOL slash L. Okay, if you remember that, you won't go wrong when working through molarity. Some people, when they are converting something like 7 micromolar, for example, they'll write something like it's 7 moles per microliter because they think the micro actually goes as the prefix of the liters, but that's not true. Okay, so this is incorrect here. You want to put the micro, the prefix, in front of the moles. Okay, and this is very easy to remember if you just remember big M is equal to MOL slash L, and just you can interchange them as you go. Now, in terms of what this physically means, it's that so let's take 7 micromolar, for example. Okay, this means that in a 1 liter solution, okay, there are 7 micromoles of something floating around. Okay, so imagine I have something and there is 1 liter in this bucket. Okay, 1 liter of, let's say, glucose. Okay, so in this 1 liter, the concentration is 7 micromolar. This is the concentration. Okay, 7 micromolar. 7 micromolar was expanded out to be 7 micromoles per liter. Okay, 7 micromoles of glucose per liter of solution. 7 micromoles of glucose per liter of the solution. And since there is 1 liter of the solution here, okay, in this 1 liter, there are 7 micromoles of glucose. If I have another solution, and this time I have 2 liters of the solution, but the concentration is still the same. It's still 7 micromolar. Okay, 7 micromolar, again, it expands out to 7 micromoles per liter. Okay, 7 micromoles in 1 liter of solution. 7 micromoles in 1 liter. If I have 2 liters of solution, okay, this means in here I now actually have 14 micromoles of the glucose swimming around inside this 2 liters. Okay, if I have half a liter of solution, I have 3.5 micromoles of the glucose floating around. Okay, so even though the volume changes here, okay, the concentration doesn't necessarily have to change, And if the concentration stays the same, the volume changes. This means that you just have a different number of molecules, different number of particles in these different containers. It's just like saying if we have two paddocks, okay, so this is one paddock and this is a different paddock over here. And the farmer says to you, well, I have 4 sheep, no, let's say I have 4 sheep per hectare, okay? So the concentration of sheep is 4 sheep per hectare, per one invisible one per hectare. And the concentration of sheep, the density of sheep, is the same in both paddocks, okay? Now say this paddock is 1 hectare in size, and this paddock is 3 hectares in size, okay? Now if the concentration is 4 sheep per 1 hectare, sorry, this means that we have 1, 2, 3, 4 sheep in this paddock here, okay? And in this paddock here, we have also 4 sheep per hectare, but we have 3 hectares. This means we have 12 sheep. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 sheep in this paddock here. Okay, so the concentration, density of sheep is the same, but because the area of the paddock or the volume of the paddock has increased between the 1 and the 3 hectares, now we have just more sheep in this area.